Every year, the United States raises over 73 million pigs, supplying approximately 20% of the world's total pork production. With more than 63,000 farms spread across the country, ranging from family-run operations to advanced industrial facilities, the U.S. pork industry has risen to become a global powerhouse in pork production. Behind this success are cutting-edge technologies, modern management systems, and stringent standards that drive the industry's rapid growth. Join us as we explore how the U.S. is revolutionizing pig farming with modern technology, enhancing efficiency and sustainability, and creating one of the most advanced pork production chains in the world. Green agriculture technology, the billion-dollar journey of America's pork industry. Pigs are raised across the United States, from family farms to modern livestock facilities. With millions of pigs each year, the industry faces major challenges in environmental management and production optimization. How does the U.S. maintain massive production while ensuring efficiency and sustainability? In the South, such as Texas, small farms often use free-range methods or raise pigs in small enclosures. In contrast, in high-production areas like Iowa, Minnesota, and North Carolina, commercial farms implement modern automation systems for feeding, health monitoring, and waste management, optimizing productivity and reducing labor costs. Pig breeds play a crucial role in production efficiency. Yorkshire pigs are favored for their fast growth rate and high lean meat ratio. Meanwhile, Berkshire pigs, known for their rich marbling and flavorful meat, primarily serve the premium market. Thanks to artificial insemination technology, farmers can precisely breed pigs with desirable traits such as rapid growth, high lean meat content, and improved disease resistance. First, breeding farms use genetic selection to maintain and enhance the best characteristics of pigs, such as growth rate, fertility, disease resistance, and adaptability to the environment. Artificial insemination, AI, is widely applied to optimize breeding. High-quality boar semen is collected at specialized centers, rigorously tested for quality, and stored under controlled conditions before distribution. On farms, technicians perform artificial insemination on sows at the optimal ovulation time to increase conception rates. Methods such as direct semen injection or deep catheter insertion help improve reproductive efficiency, reduce the number of mating attempts, and optimize livestock performance. After breeding, sows are pregnant for about 114 days. During this period, they are kept in separate areas with a specialized diet to ensure their health and optimal fetal development. Pregnant sows are housed in separate areas, usually well-ventilated barns with stable temperature control to create ideal conditions for fetal development. They receive a specialized diet with higher levels of protein, minerals, and vitamins to support fetal growth while preventing excessive weight gain, which could lead to birthing difficulties. Automated sensor systems monitor the health of pregnant sows, tracking their feed intake and detecting abnormalities such as weight fluctuations, reduced appetite, or signs of stress. Near the due date, sows are moved to specialized farrowing pens equipped with heated flooring and strict environmental controls to create ideal conditions for birthing. Each piglet is born approximately 15 minutes apart, and the entire birthing process can last between 2 to 5 hours. Newborn piglets are wet and at risk of rapid heat loss, so they are immediately dried and kept warm in an environment of around 75 to 77 degrees Fahrenheit. One of the most critical steps is ensuring piglets nurse colostrum within the first 6 hours after birth. Colostrum contains essential antibodies that strengthen the immune system and protect piglets from diseases. If piglets are weak or unable to nurse, farmers assist by manually extracting sows' milk and bottle feeding to ensure all piglets receive the necessary nutrients. To prevent piglet crushing, where the sow accidentally lies on her young, farrowing pens, are designed with protective rails, giving piglets a safe refuge. Additionally, some farms use heat lamps or heating pads to create a warm zone that encourages piglets to move away from the sow when not nursing. In commercial farming, piglets are weaned at around 3 to 5 weeks of age. During this phase, they gradually transition to highly nutritious starter feed to prepare for later growth. After weaning, piglets require a special diet to grow healthily. Their feed mainly consists of corn, soybeans, fish meal, or milk-based protein, combined with minerals and vitamins to boost immunity. In the early stages, piglets are fed starter feed rich in protein, available in small pellets or fine powder for easy digestion. Later, their diet transitions to grower feed with a reduced protein content of 18 to 20%, supplemented with extra energy to promote growth. Most commercial farms store feed in silos or large containers, while some farmers grow and process their own feed to control costs. Proper nutrition ensures rapid growth and prepares piglets for the next fattening stage. Modern technology not only increases productivity, but also significantly improves farm hygiene. Automated cleaning systems, including high-pressure washers and disinfection mechanisms, help maintain a clean environment, reduce disease risks, and cut manual cleaning labor by up to 40%. In the long run, this optimizes costs and enhances farming efficiency. Modern farms maintain hygiene through automated cleaning systems, climate-controlled ventilation, and slatted flooring that removes waste efficiently. These measures keep barns dry, reduce disease risks, and optimize pig care. Waste management and pig manure recycling play a crucial role in environmental protection. Modern farms implement waste treatment systems such as biogas digesters or anaerobic digesters to separate solid and liquid waste. Liquid manure can be used as natural fertilizer for fields, while solid waste is composted into organic fertilizer or converted into bioenergy. Advanced technologies like automated sludge discharge systems are also being implemented to reduce labor costs and improve processing efficiency. When pigs reach a market weight of approximately 280 to 300 pounds, they are transported to processing plants under strict welfare and quality control protocols. Before leaving the farm, pigs are given a fasting period of 12 to 24 hours to reduce gastrointestinal stress, while ensuring they have access to fresh water. Transportation usually occurs in the early morning or late evening to avoid high temperatures and minimize health impacts. Specialized trucks with ventilation systems, non-slip flooring, and partitioned sections help reduce stress during transport. When loading onto the trucks, pigs are guided through low-gradient ramps to ensure smooth movement and prevent panic. Upon arrival at the processing plant, pigs are not immediately slaughtered, but are instead allowed to rest for about 2 to 4 hours in an area equipped with drinking water and cooling systems. This recovery period helps relax their muscles and improve meat quality. They are then moved through a humane processing line to ensure the best meat quality before reaching consumers. Advanced automated systems handle and inspect each pig, followed by cleaning processes such as scalding to remove hair and surface sterilization. After the pigs are cleaned with hot water, a dehairing machine removes most of the hair from the skin surface. Next, the pigs pass through a singeing chamber where high-temperature flames burn off any remaining fine hairs and sterilize the skin. The final cleaning process is carried out using brushes and high-pressure water to ensure the skin is completely clean. Afterward, the meat is rapidly cooled to prevent bacterial growth before moving on to the sorting stage. Cuts such as tenderloin, ribs, and pork hocks are trimmed and packaged according to strict inspection standards. Byproducts such as fat, bones, and organs are collected for the production of animal feed, pharmaceuticals, or other products, optimizing the supply chain. The meat cuts are trimmed to standard sizes, ensuring suitability for various purposes. Larger cuts such as tenderloin, ham, and shoulder are divided into individual portions, ready for processing or retail sale. Trimmings or pieces unsuitable for portioning are sent to an industrial grinder, producing finely ground meat with controlled fat content. Additionally, pork is used to make processed products such as ham, sausages, cured meats, and bacon. Finally, each batch of pork undergoes quality inspection before being transported to supermarkets, restaurants, and food processing plants. The entire process is closely monitored to ensure pork remains safe and fresh for consumers. U.S. beef stands out as a symbol of premium quality and exceptional flavor. With a strict grading system, beef is categorized into distinct grades, ensuring that every cut reaching consumers meets the highest standards. In 2020, the United States consumed approximately 13.8 million tons of beef, accounting for 21% of global consumption. Solidifying its leading position in the global beef industry. Join us on the fascinating journey of beef before it becomes a beloved dish enjoyed by many. Green agriculture technology, the impressive journey of millions of tons of beef. Before becoming a premium ingredient for exquisite dishes, beef must undergo a strict processing procedure to ensure its quality and perfect flavor. The carcass is thoroughly cleaned, with the skin, hair, and internal organs removed, while unusable parts are processed separately to optimize resources. Next, the meat is washed and transferred to the cutting stage, where skilled butchers or modern machinery divide it into standard portions. From large cuts to smaller pieces, suited for various uses. After classification, the meat is rapidly cooled to a temperature of 0 to 4 degrees Celsius to prevent bacterial growth and maintain freshness. Each stage is strictly controlled to ensure that the meat is not only of high quality, but also absolutely safe, providing consumers with the freshest products. After initial processing, the beef is transported to processing plants, where it is transformed into a variety of products to meet market demand. Corned beef is a beloved dish, appearing in classic sandwiches or pairing perfectly with cabbage. With its rich and distinctive flavor, making it a popular choice. Corned beef is processed into various forms, the most common being sliced meat, often used in sandwiches or served with eggs, and mincemeat, suitable for dishes like corned beef hash or canned for convenient storage and use. The process begins with the selection of beef, typically brisket or round cuts, which have an ideal texture for curing. When the meat arrives at the factory, it is thoroughly inspected, cleaned, and trimmed to remove excess fat or unwanted connective tissue. The meat is then divided into appropriately sized portions, ready for the curing process, which creates the distinctive flavor of corned beef. Curing is a preservation method using salt, which not only extends shelf life, but also enhances the color and unique taste of the meat. The beef is soaked in a special brine solution containing salt, nitrates to retain color, and spices such as mustard seeds, black pepper, bay leaves, and cloves. The curing time can range from a few days to a week. To ensure even flavor distribution, some manufacturers use injection techniques to directly introduce the brine into the meat. Once the curing process is complete, the meat is washed to remove excess salt and spices. At this stage, the meat becomes firm, develops its characteristic pink color, and is ready for cooking. Corned beef is typically slow-cooked in steam ovens or large boilers for several hours, ensuring tenderness while preserving its rich flavor. Corned beef can be vacuum sealed in airtight plastic packaging or canned for long-term storage without refrigeration. These products undergo strict hygiene and quality control before being distributed to stores worldwide. Not only corned beef, but many other types of meat also undergo elaborate processing to create distinctive products. One of these is salami, a famous dry sausage known for its rich flavor and unique texture. The process begins with selecting high-quality pork or beef, which is then finely ground and mixed with salt, garlic, black pepper, wine, and other signature spices. This mixture is stuffed into natural or synthetic casings and then undergoes fermentation to develop its characteristic taste. After fermentation, the salami is dried under strictly controlled temperature and humidity conditions for weeks or even months, allowing it to develop a firm texture and deep, rich flavors. Some varieties are lightly smoked or coated with natural mold to enhance the aroma. Once perfected, salami is ready to be sliced and enjoyed, a delicacy steeped in tradition and refined over time. From fresh beef cuts The sausage-making process begins with a delicate balance of modern techniques and traditional recipes. The beef is finely ground together with animal fat to add richness and bind the mixture. This blend is then thoroughly mixed with salt, spices, and food additives to improve texture and extend shelf life. Once achieving a smooth and consistent texture, the meat mixture is stuffed into sausage casings, either natural casings made from animal intestines or artificial collagen casings. Next, the sausages are either smoked or steam cooked, depending on the product requirements. This step not only preserves the sausages, but also enhances their distinctive flavor. Finally, the sausages are rapidly cooled, vacuum sealed, or frozen to retain their freshness before being distributed to the market.